the location of nodes. Now that's the next topic on the list after we have already understood how to choose a certain element for a certain structure. However, of course, nodes will appear at the vertex of every element. So if we have to make sure that when we are dividing a certain geometry into subdivisions, then the nodes are placed in the correct location so that they do not introduce any kind of discontinuities in the structure. Okay, so we can look at some examples. If, for example, I have a cantilever beam, very simple one, of course. I have a simple cantilever beam with an end load on it. Then I see that there are two introduction points. One is this section where the load is introduced and this where the constraints are. So if I'm going to make a finite element mesh, then I will make sure that I have a certain wire like this. And if I want to introduce one element, then it's one element, but otherwise I will place the nodes somewhat equally distributed, or however I would like to have it, such that there is always a node where the constraints are applied and where the loads are applied. So these two nodes become absolutely necessary. Now, for example, if I have a cantilever beam, the same one, simple cross section, but instead of having the load at the edge, I have a load somewhere here. So I need to make very sure that there has to be a node at this location and at this location, because I need to have a node there or a point there to introduce a load. So what I can do is a simple discretization is to have two elements. So one element, one node here where the load was applied and one here where the constraints are. So this is something in terms of load introduction point. What if I have a cantilever beam, but that cantilever beam has a cross-sectional area that varies? Suddenly at this location, I have a change in the cross-sectional area. So that's also something I need to make sure of in the discretization. So here too, I will have two elements, one with area 1, one with area 2 at least. I could also have multiple elements with area 1 and multiple elements with area 2. However, this discontinuity always must be present because I need to have a change in cross-sectional area here, and here I must have the constraint applied. Right? So these are certain things that we always have to make sure that we have in a certain structure. So let me give you one more simple example. I mean, I'm not sure if we are going to use it, but you have seen this in some problems before, so it might be interesting. What if I have a plate? Because I like plates. I have this plate here, and I'm not going to use a hole, but I'm going to say there is a small crack over here. Yeah, so actually this part doesn't exist, or crack or a notch. Let's go with a notch. So I need to make sure that when I discretize this part into certain number of elements, so if I say, okay, I start making elements, 2D elements because it's a plate, I have to make sure that there are nodes that exist here and here, and most likely all along this curve, so that I can see this as a notch. So these are the important discontinuities that to show that they exist, whether it's a load introduction point, whether it's a change in the cross-sectional area, whether it could also be a change in material property. For example, if I have two plates that are lying right on top of each other, and one of them is made of, I don't know, aluminum, and the other one is made out of steel, then I have to make sure that I have nodes that are enforced in between, because this will be one part A, and this will be part B. So I must make sure that the nodes exist at this discontinuity of the two different kinds of materials. So this is something about how you have to make sure where the location of nodes is. Now in Abaqus, what you do is that you can partition parts. So you can say that I partition this cantilever beam into two parts right here at this point. Same here, you can partition it here. Yeah, so you can create then two parts which have different sectional properties, which have different meshing. So you have physically created a point at this location which is required. In Patran, you don't have to do you don't have to make a partition, but you can actually create two parts. You can also add a point, and after you add a point, you can say I want to associate this point to the geometry, so the point becomes a part of that. This new point becomes a part of that curve or that line that you created. You can also break it up into different elements. You can also say I want to have elements from this length to this length. Yeah, this would be one element. So there are some ways of creating these discontinuities by introducing node locations. And if you go through the list of all the possible options in your finite element software, you'll find that they're quite easy. And yeah, once you have some experience, it'll just come naturally to you. But in general, it's very important to know that the location of nodes actually plays a very important role in discretization.